Here we go. So, like I said, we have looked at systems where there's a definite solution, there's no solution, then there are infinite solutions, and we have some practice with that. But let's see what this one gives us when we figure it out. So we have 4x plus y. Sorry, 4y plus x. That's my dyslexia kicking in. 4y plus x equals 20, and negative y minus 1/4 x equals negative 5. So here are our two um, systems, or our two equations in the system. And if we wanted to manipulate this, and we're going to need to because we can't just uh, one won't just go into the other and cancel each out. So we can solve one for one variable in terms of the other. And so what we have to do is we're going to need to manipulate one of these equations. So let's see, how's that going to work out? Let's get rid of our y. And I think if we do this, my plan is to take the second equation. I'm going to multiply the whole thing, multiply by 4. Okay, now if I multiply the bottom equation by 4, I'll end up with negative 4y, which will cancel out the positive 4y in the top equation. So I'm going to rewrite my equations here. I've got 4y plus x equals 20. Okay, now 4 times negative y would be negative 4y. So that's good. That cancels that out. Negative 1/4 x times 4. Well, what is 1/4 times 4? Well, let's go over here. 1/4 times 4. You should remember. It works out pretty nicely. 1/4 times 4. 1 times 4 is 4. 4 times 1 is 4. So you get 4 over 4, which is just 1. So this would be negative 1x, or just negative x. Oh, okay, that works out nicely. And negative 5 times 4 is negative 20. All right, now when we go to combine these two equations, 4y and negative 4y cancel each other out to make 0. Positive x and negative x, they cancel each other out to make 0. And 20 and negative 20, well, they make 0 also. So what we end up with is 0 equals 0. Does 0 equal 0? Is that a true statement? It absolutely is. 0 equals 0. That's true. That is true 100% of the time. So to come up with a set of solutions to this, because it's a true statement, there will be multiple solutions, many solutions, an infinite number of solutions. Okay, but we'll just say many solutions. All right, lots and lots and lots of them. The trick to finding the trick to finding what the solutions will be lies in if, let's say we take this equation right here, 4y plus x equals 20. If I put in a value for x, let's say I put in 0 for x, right? Then I have to solve the rest of this for y. So this would be 4y plus 0 equals 20. Subtract 0 from both sides, so I would end up with 4y equals 20. Divide by 4, and y equals 5. So that's one solution. 0, 5 is a solution. And then I could do that same thing all over again by substituting. Let's say if I want to say, all right, well, what if x is 1? Then if x is 1, then I would have 4y plus 1 equals 20. 4y plus 1 equals 20. Subtract 1, subtract 1. Oh, you know what? How about life's going to be harder that way. How about the reason I'm going to do this is it'll make sense. I'm going to change my x to 4. So we'll make that 4 instead of 1. So subtract 4, subtract 4. So that when I do that, I get 4y equals 16. Divide both sides by 4. and y equals 16 divided by 4, which is 4. So that's another solution. And you can just keep substituting values in for x, solve for y to figure out what the other one is. But and you could do it an infinite number of times to figure out what that is. Now, let's scroll on down here to number 10, where it says to create a system of equations that has no solution if one of the equations in the system is 3x plus 2y equals 8. Okay, so they're giving us one of them. 3x plus 2y equals 8. Well, how can we have a system that has no solution given this set right here? Well, it's really, 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 really simple. So I want you to pay very close attention to this. So check this out. If I take this equation that I have right here and I multiply that by another number, any number, doesn't matter what it is. Let's say -2. Okay. So 3 times -2 would be -6x. 2 times -2 would be -4y. All right. But I'm not going to multiply the constant right here by -2. That's not going to happen. I could leave it the same, or I could multiply it by something else entirely, like maybe -1. Okay. Whatever it is, you just don't want the number that you're multiplying this side by. Okay. You don't want it to be the same as what you multiply this over here. I can guarantee that there will be no solution to this equation when you go to solve this system of equations. So just to prove my point, let me show you what I'm talking about. All right. Okay. Graphing calculator. I'm going to Desmos. I'll do a new share here. So when I go to type in that first equation, I had 3x plus 2y equals 8. All right, so there's that equation. Now, this next one, when I multiplied one side by -2, -6x minus 4y equals -8. So you can see all I did was create another line that's parallel to the first line, but crosses the y-axis someplace else. So like I said, all I had to do was to multiply the left side of my equation by something, but multiply the other side of my equation by something else entirely, and you'll have no solution whatsoever. So that's pretty cool. Now, what if? All right, now create a system of equations as we move on to number 11. Create a system of equations to satisfy the following conditions. How about a system with one solution? Well, that's creating a system of equations with one solution is really, really simple. You just have to make sure that pretty much everything is different. All right. So let's say 2x plus 3y equals 4. But here's what you don't want to do is you don't want everything to match up on either side. So we could say 3x plus 3y equals, you know what? I'm just going to make those exactly the same, except for that one thing. Okay. So let me show you really quick what that looks like in Desmos. 2x, and I know you're not seeing it just yet, but you will, plus 3y equals 4. And 3x plus 3y equals 4. And I'll show you what that looks like in Desmos. And you can see that they definitely have a point of intersection, right? You just want to make sure that there are differences, and you're not just multiplying everything through by the same number in the second equation as you did the first, or anything. All I did was change one of my coefficients, and I can come up with a solution, one solution. I could have changed two things. I could have changed one of my coefficients. Like I could have changed 3y to, how about 4y? You can see they still have an intersection. All right. And then I could change my thing there. And if you look down here, there will be an intersection right there. Okay. There has to be differences, but they can't be like where you've multiplied one side by one thing and one side by the other. There's a definite way that you want to do that. Okay. So given that, how about a system with many solutions? Now, this is probably the easiest one to do. A system with many solutions, you just have to say, all right, well, how about, I'll use that same equation, 2x plus 3y equals 4. But watch what I'm going to do. I'm going to multiply everything in this first equation by something, the same something. So how about I'm going to multiply everything in that first equation by 3. So 6x plus 9y equals 12. I've multiplied everything by that same number, 3. When I do that, when I go to graph it, my graph will look just like this, or something. It'll, and exactly right on top of that, because all you've done is taken that exact same line equation and multiplied it by a random number, but it's still that when it's simplified, it'll still be that same line. Trust me. And then when you want a system with no solutions, all right, a system with no solutions, I'm going to take that same equation I had, 2x plus 3y equals 4. If I wanted to have no solution, well, on this side, I could multiply by whatever. How about I multiply this side by 3? So this would be 6x plus 9y equals, but this side, I'm not going to multiply by 3. How about I multiply by 2, right? So I get 8. I can guarantee that there will be no solution for this equation. That's the simplest way to do it. Multiply one side by one number and the other side by any other number, and there will be absolutely no solution because all I've done is produce two parallel lines. It's as easy as that, folks. You can do this. All right. So let me stop the recording here.